Welcome to Deliverable 4 and the team final project presentation for the Fired Up Benchmarking Dotadrones project Knowledge-Based Lab Interpretation. My name is Chad Hansen and I will be your narrator. In this presentation, we will discuss the healthcare problem core to this project and a solution designed to address it. Then we will see the application implemented, including a demonstration. Finally, we will discuss next steps and future possibilities. Let's start with the problem. Medical literature describes how various lab tests can be used to assess liver function. In 2011, Chevrier and colleagues developed a set of rules using up to 11 measurements to assign patients one of 24 diagnoses. Consider the LFT rule set shown here. While effective, the complexity makes manual use time-consuming and error-prone. Additionally, previous efforts to automate LFT clinical decision support failed to consider the breadth of clinical knowledge available about a patient and were EHR or hospital specific. Our team took a new approach. There are a few key project goals and objectives. First, providing clear understanding of liver function test results. Since the LFT rule set is complex, user-friendly clinical decision support is critical. Second, automation via a computer application ensures accurate and efficient interpretation. Next, patient data is retrieved from the electronic medical record. Using a standard FHIR'ed interface to do so provides interoperability. Finally, with clinician workflow in mind, a Smart on Fire application makes the functionality most accessible. Now some details about the implementation. Over the past few weeks, we've refined the individual application components and integrated them for a seamless user experience. At a high level, as front-end developer, Brendan polished the web-based user interface. Our back-end developer, Gordon, expanded the code, support, rule set, and patient test data. As architect, Chad refined the deployment mechanisms for sharing the app with TA and external mentors. Finally, as project manager, Mike drafted documents, performed user testing, and assisted with front-end development. Referencing the architecture diagram, let's explore the current state of our application, one component at a time. Georgia Tech's FHIR servers don't contain observation data needed to exercise our application. So Chad and Gordon configured a FHIR server populated with relevant test data. Here we see an observation with LOINC code 1742-6, a liver function test. Successfully deploying a FHIR server with the correct app data, both in Docker and through HDAP, was a significant and ongoing effort. Eventually, our Smart on Fire app would be integrated with an EHR, eliminating the need to manage its own data. To make the liver function test rules easily maintainable, Mike designed a spreadsheet that is human-readable and intuitive to edit. After updates and additions are made, it is saved as a set of TSV files automatically read and processed by the app. Here we see 3 LFT rules with corresponding text to display if they are triggered. This system scaled nicely when Dr. Park added 14 new rules and the app readily incorporated them, growing the functionality and value 5-fold. Data validation could be added here to prevent user inputs that would cause the app to fail. Gordon wrote the server-side application code, which retrieves patient data from the FHIR server, applies liver function test CDS rules against it, and returns findings and recommendations. The app makes every relevant patient observation available to the clinician user in a meaningful way. This is a huge step forward. Looking ahead, a natural extension would be to collate and analyze these discrete data groups to identify patient health trends over time. Brendan developed a user interface tailored to busy clinician providers. The clean design minimizes visual distractions and is inviting and intuitive to use. As shown here, it is also responsive and works well on mobile devices. A possible refinement is replacing some text elements with icon to further streamline the user experience. The application and FHIR'ed server are deployed using Docker. So after receiving the source code, our external mentor can run the application locally with the command docker compose up. Additionally, Jenkins provides continuous integration and automatic updates to the Georgia Tech HDAP server, so our TAs can use the application by connecting to the VPN and navigating to the hosted site. To simplify both deployments, the FHIR'ed server with test data is stored on Docker Hub, a public registry for Docker images. Now for the exciting part. Let's see the application in action. Here we have the application's landing page. This page is useful for easily switching between the sample data patients. In a fully deployed system, this functionality would be in the EHR. Selecting a patient allows us to see the patient's name, a selectable list of lab test dates, the lab test results for the selected date, and most importantly, the interpretation of those lab results. These are the triggered clinical decision support rules for the patient's current results. Each triggered rule displays a summary name and description, along with a link to source material. There's also a More link that reveals a more detailed description of the triggered rule. Finally, clicking on the header will take you back to the patient selection page. A clinician using this application would start by selecting the patient they are working with, selecting the date for the LFT results they are concerned about, and then seeing the triggered CDS rules that would help them better understand the results, potential issues for the patient, and suggested actions for their condition. That's the current state of the application. Let's talk about what's next. Going forward, the team has many options to consider. First, Columbia Medical Center is looking for Smart on FHIR'ed app use cases. So, our mentor, Dr. Park, will share our project there and explore follow-on activities like usability testing and research. We may also submit our project to a government or academic challenge designed to stimulate CDS application development. Finally, we could expand the application's functionality to include CDS hooks and integration with EHR vendor products, ultimately leading to a commercial offering. In any case, we take great satisfaction in delivering to Dr. Park a compelling and fully contained proof of concept for a Smart on FHIR'ed app that provides liver function test clinical decision support. More broadly, we have demonstrated the ability to effectively provide, as the project name suggests, knowledge-based lab interpretation.